I'm back. We're on the bottom of page 300, and we're going to knock out this page, and then we're going to take on the next page and see how it goes. So this says use SOT and or its derivative to find the times at which the car's velocity is 0. So I think that the easiest thing to do here, since we have position, and then the rate of change of position is velocity. So I think what I want to do is I want to find when S prime of t, which is equal to V of t, equals 0. And I'm just going to let the calculator do the work on that because SOT is kind of gross. So if you remember, I already have SOT built in here, or defined. It's not built in. And I want to find when the velocity equals 0. So I have a couple of options here. One of them is I can solve. So I'm going to solve the derivative with respect to t, because that's the independent variable of S of t. So that'll be velocity is equal to 0, and I want to solve that for t. I only care about 0 to 35, but let's see what I get. So I get 0, okay. I get 35.0. So there's the only time on the time interval is actually at 0, and then it's just like it's slowing, I guess, because the next time it's 0 is 35.0362. But the only time it's actually 0 on the interval is at t equals 0. So that's kind of cool. All right, so let's see what the next problem is, and also I'll jot that down. So let's see. Jot that down. I wonder what that really means. To jot. J-O-T, I assume. Gives me t equals 0 on 0 to 35. It's the only time that happens. All right, the next question says, having trouble scrolling here, says that there is a time. It doesn't say is there. It says there is a time when the car's velocity is at a maximum. How can we find the maximum velocity of the car? All right, so I have a couple thoughts. We know how to find the velocity as a function, so we could just graph the velocity and then use the calculator to find the maximum, right? So that's one option. So one would be to graph v of t and then find the max. But that's not a very calculus way of doing it, but it'll work. I think a better idea is, what if I found the derivative of velocity and found where the derivative of velocity changes from positive to negative? So if I can find, I'm going to find v prime of t, which if you're in physics or you just pick this up along the way, you know that's the acceleration. Find that, and then find where, that says where a of t changes from positive to negative. Okay, so let's see, does it ask me to do it? It doesn't actually ask me to do it. It just asks me, like, can I do it? Yeah, I can do it. I have a plan, but let's actually do it. Let's see what we get. Let's do this. Switch over to your calculator. Bust it out. Let's do this. All right, so all right, I'm going to start off by graphing the function. Let's see. So graph. I'm going to graph the So I'm going to graph the velocity, right, which is the derivative of position. So the derivative, I have to use x though, but the calculator doesn't mind that, right? So I defined s as a function of t. Now I'm changing to x. The calculator is fine with it. I could define this a function of anything and change it to x. The calculator will be like, yeah, that's cool. So here's our graph of velocity. So let's see what we should change this to. So I know that I want this to go from, like, let's say -2 to 37, right? Just so we can see everything that we want. I really don't know what to do here. I'm going to go -5 to like 100, and if that's enough, good. If it's not, I'll change it again. That's pretty good. Okay, so I'm looking for the maximum of this, so I could just use menu 6, 3, and then click, drag, and click. Okay, so I get that. That's fine. So the maximum of the velocity occurs when time is 4.270, and the maximum velocity is 75.164. My other idea was that I would graph the derivative of velocity, which is acceleration. Watch how I do this. Derivative with respect to x of, so I want the derivative of velocity. Right now, velocity is in F1, and I'm gonna press enter. Okay, so now with this approach, I wanted to find when the acceleration changes from positive to negative. You can kind of see it's probably going to be 14.270. The way I like to find that is I'll also add 0, do menu 8, 1, 4, click, click. There, that is the time at which the acceleration, which is the derivative of velocity, changes from positive to negative, is the time at which velocity changes from increasing to decreasing. And when velocity changes from increasing to decreasing, velocity had a maximum. So that's a great question. That would be my answer. I think that's a good answer to that question. A lot of information, a lot of connections. Can't stress it enough. You gotta take responsibility and try to make these connections make sense to you. And when they don't, you have to ask. Because like we're not there. Like you gotta put in the effort. All right, is there a time when the car's instantaneous velocity is equal to the car's average velocity on the time interval? Okay, so average velocity was the average rate of change of position on the time interval. So that will be S of 35 minus S of 0 over 35 minus 0. Okay, that's the average rate of change of position, which is average velocity. We want to know if that ever equals the instantaneous velocity, which is v of t. Okay, so let's do that. Let's see if this has any solutions. So back to the calculator. And maybe we'll do that on a calculator page, I guess. So we want to solve S of 35 minus S of 0 over 35 minus 0 equals the derivative. I should have stored this at some point, but I didn't. So the derivative of S, which is v of t, and solve for t. So we get, there's actually 2 times, it turns out, on the interval from 0 to 35. 5.363 and 25.099. So let's write those down. So I'm gonna go back to the notes and put this in. So we got t is approximately, because it's definitely not exactly anything, 5.363, and also 25.099, and both of those are seconds. It's actually 2 times at which that happens. So let me go back to the calculator for a second. And I'm gonna go to, I'm gonna put in a new graph page. And I'm gonna regraph the velocity, right? Which is the derivative of position. So I wanna regraph this. I think we used a window that was pretty good. So like -2 to 37, and then like -10 to 100. Okay, and then I'm gonna add to this S of 35 minus S of 0 over 35 minus 0. So I'm adding the average velocity on the interval. So I get this, and you can see that there should have been 2 answers. There were. Let's do menu 814, 813 if you have a CX1. So I get these, 5.363 and 25.099, like I got when I did it using solve. You always want to try to do it graphically and do it like algebraically using the cast feature, because sometimes one of those will fail, sometimes the other will fail. You need to know both methods. So I'm going to stop this here. I'll come back and we will potentially finish this page in the next video. So I will see you then.